Hello, everyone. So this is a quick review of bounds because I didn't get the chance to do this in class, but you'll see it's pretty simple and you should pretty much remember it from last year as soon as I explain it. So first definition here is that a sequence is bounded above if all the terms of that sequence are below a certain number m. So here we didn't specify this here, but this is a number. All right. So the example we give here is a sequence an equals to minus n, which is minus 1, minus 2, minus 3, minus 4, and so on. But more importantly, what does this look on a graph? So if I graph the sequence, we said that it begins at minus 1. So I'm sorry here, I'm not going to write my scale because it's a little bit too complicated on the computer. But you've got the points. This point here has an equals to minus 1, minus 2, minus 3, minus 4, minus 5. So anyways, you see that this is basically this decreasing sequence right here. And it's bounded above if there's a number that is above all points. So here it's pretty obvious to see what that number could be. There's obviously several answers that would work, but one obvious choice would be 0. So 0 here would be equal to m. So we would say an is going to be smaller than or equal to 0. Or minus 1 would also work in this situation because it's possible to be equal. Now we've got the other sequence, the other definition that says it's bounded below if an is greater than or equal to small m. We use small m for the lower one and big M for the upper one, just because it makes sense. So again, if I go ahead and draw the sequence an equals to n is just 1, 2, 3, 4, 5, 6 until infinity. So again, being a little bit creative here, these are all the points of the sequence. So this here is obviously not bounded above because if I would pick any number m on the y-axis or an axis in this situation, there would always be a number that is above it. However, there's a number that is below it. For example, here, 0, again, could be a lower bound, or 1 could be a lower bound. So I'm gonna decide to go for 1 for this one, for no particular reason. So I could say an is greater than or equal to 1 for this whole sequence. All right. Now the last definition basically wraps up everything. So a sequence is said to be bounded if it is between m and m. Therefore, it means that the sequence has both a lower bound and an upper bound. If that's the case, it is bounded. An example of this would be the sequence an equals to 1 over n, my favorite. If you remember what this one looks like, the first term would be 1, second term is 1/2, third term is a third, 1/4, 1/5, 1/6, and so on. So this here, let's see, it has an upper bound because you see this is decreasing. Therefore, it's never going to be going above the number 1. So this here would be my big M because it's the upper bound. And then we would also have a lower bound because this is never going to be negative. So we could set 0 to be our lower bound. So the sequence is bounded because it is bounded by 0, n, I'm going to call it an, and 1. There we go. Now, very important note, every convergent sequence is bounded. That means that if you find out a sequence converges, you know it's bounded. That makes sense because if it were not convergent, if it's divergent to infinity, for example, in this case here, it cannot have an upper bound. Therefore, it's not bounded. So any convergent sequence would definitely be stopping at some point. It would not go to infinity. So that's the idea behind it. But we have to be careful because the inverse is not true. It's not true that every bounded sequence is convergent. And the example for this here is the sequence -1 to the power of n, which we know to be divergent because the limit does not exist. So if you recall, this is the sequence -1, 1, -1, 1, like this. So this is divergent, but it's bounded because the sequence goes between -1 and 1. The point of this that's really essential is you could calculate the limit of a sequence, and if you find out that the limit exists, you find that L is a number, then you know for a fact that your sequence is bounded. So for example, if I ask you in the following 3 example, is a sequence bounded? The first thing I'm going to do is go ahead and calculate the limit. If I know the limit exists, then clearly it's bounded. So let's do that. So the limit as n approaches infinity of n divided by n plus 1. If I first substitute for infinity, like I taught you to do in class, you would get infinity over infinity, which you know to be indeterminate. Now we need to figure out a way to get around this indetermination because, as you know, it's not an answer. And one way for that would be to use the factoring method. So if I factor n on the bottom, I'm going to be left with this expression. Therefore, as I evaluate the limit, I'm going to get the following. 1 plus 1 over this thing here. This one goes to 0, meaning you're left with 1. This is a number. So our answer here will be that this here is convergent, which means it is also bounded. Next one, is n squared over n plus 1 bounded? Let's see if it's first convergent. If it goes to infinity, we'll know that it's not bounded. I'm sorry, I have some trouble writing right now. All right, so the limit as n approaches infinity of n squared over n plus 1. Again, infinity over infinity. So let's factor this one out exactly like I did above. So n squared, bottom is going to be n times n plus 1. No, never mind. N squared. So this one's going to be n, 1 plus 1 over n. That's a squared. All right, so the square is going to cancel with the one at the bottom. We're going to be left with infinity over 1 plus 1 over infinity. This is 0. You're overall left with infinity. This means that the sequence is it's increasing to infinity. It's a case where it looks like this. Not too sure how. It's probably not a straight line, but somehow the n when you're approaching infinity, it keeps on growing. That's the point. Therefore, we know it's divergent, and we know that it's also not bounded. Unbounded. This is a very terrible B, but it's a B. All right, and the last one, minus 1 to the power of n, already discussed, and that is it for boundness. So this is just basically your interpretation of the limits. That's all it's adding. If you have any question, please just email me or come during consultation, and I will gladly answer